An example might be R equals 6 cosine 3 theta. Tell me about that. That is a rose. What can you tell me about that rose?
It's got 3 thick rows. 12 or something.
One of the thickest roses I've ever seen.
3. I'm locking in 3. It's 3.
It has 3 leaves, and they're 6 units long.
Oh.
As opposed to 4 cosine 8 theta.
Oh, that's a lot of things.
4 cosine
I
6
can't even tell that
theta
high.
12 leaves.
would have 12 leaves, and they would be 4 units long.
If it's even,
Right?
it's odd. It's
Now, did we talk about theta step yesterday? Okay, we need to do that then today. So here's what I want you to do. I don't know whether you changed anything from yesterday or not, but go in mode, make sure polar. Hey, stop. Make sure polar is highlighted. And then in window, we're in degrees. Oh yeah, also in mode, we're in degrees. And then we're going to go from 0 to 360 because we're in degrees. If we were in radians, we'd go from 0 to 2 pi. For now, have theta steps set at 5. And then your x's from -10 to 10, and your y's from -10 to 10. Tom?
What does a theta step do?
We're going to talk about that. That's the purpose of this conversation, okay? Now, let's put in this equation right here. So we're putting in 6 cosine 3 theta. All right, did you get a 3-leaved rose? Does yours look like it's not quite even?
Yeah, that one's longer.
Yeah, but it's really not. Here's the situation. Go ahead and go to Zoom. Go to Zoom.
I think that is the situation.
And go down to square. Zoom square. Now you will see a more accurate depiction. Let's talk about that for a minute, and then we're going to talk about theta step. What shape is your screen?
It is
It's a rectangle, and you can't change that. So when you set your x's and y's from -10 to 10, automatically the units in the x direction are going to be bigger than the units in the y direction, because that's the way the calculator was built. Why they didn't build it square is beyond me. It would have made so much more sense. But if you want an accurate picture, all you have to do is hit zoom square, and it will square your screen for you, make the adjustments, and you'll get a better picture. Okay? Understand that everything you graph is warped because of the rectangular screen. So zoom square it, and you'll get a perfect picture. All right, now, let's go back to our window and change theta step to 0.5.
Oh,
And then hit graph again. Now you are going to get exactly the same picture, but what's happening? It's much slower.
why?
When you set the step, what you are telling the calculator is, okay, you have it set, it's to go from 0 to 360. So the calculator's plotting points. If your step is at 5, then it's going to plot a point at 0, at 5, at 10, at 15, and 20, and so on. So it's plotting these points. When you set your step at 0.5, it's still going to 360, but it's plotting a point at 0.5, 1, 1.5, 2. What's happening? It's plotting a ton more points. Now, what's the good news about that? You're going to get a better picture. The more points you plot, the smoother your picture is going to be. The problem is, it can take forever. Now, go back and set your theta step at 30.
It's going to be so quick.
Now you're graphing the same equation, but it doesn't look like it, does it? Because when you set your step at 30, it's not plotting enough points. Anytime that you get jagged edges, and sometimes it'll come out looking like this, anytime you get jagged edges, it means that your step is not small enough. Usually if you're in degrees and you're going from 0 to 360, usually 5 is a decent step. But sometimes you have to change it. If you ever see jagged edges, straight lines, V's, if you ever see that, you need to change your step, make it smaller. Okay? Now, we had concluded our discussion yesterday that if this number is even, we have double the leaves. If this number is odd, we have that many leaves. So, the packet I gave you, look at the very front page of it, it's got some old quizzes on it. And the very first question on your packet for this chapter is, the equation 7 cosine 2 theta is a rose. How many leaves does it have? I expect you to be able to answer that question without a calculator. How many leaves does it have? 4. How long is each leaf? How long is each leaf? 7. Perfect. Look down at the quiz underneath that. Number 3. How many leaves does R equal 3 sine 4 theta have? 8. Look at the one over to the side. Number 2. How many leaves does 4 cosine 3 theta have? 3. Okay, so we got the rows covered. All right, now we're going to graph a new equation. Let's leave everything the same on our calculator, and let's graph this equation. So let's put this one in, take the rows out. We don't want that anymore. Make sure you put your step back at 5, please. My window is still messed up from being squared, so I'm going to change my window on my X's. I'm going to go from -6 to 6, and likewise on my Y's, and I think I'll get a better picture. So my X's and Y's I changed to -6 to 6.
What's the?
Now you did not get a rose, did you?
Because
Nope.
it's just a 1.
What did you get? I heard somebody say it, I think.
It's just a 1.
Did you get a shape that looked like this?
That's weird.
That's called a lima sign. And I remember lima bean, exactly. I remember it looks like a lima bean. Now, go ahead and sketch the same equation, but make the cosine a sign. What happened? It like rotated, right? Which makes sense again because, I mean, it's the same shape. Sines and cosines have the same shape. It's just a matter of orientation. So this is just the same lima bean, it's just situated differently. Now, make this change. Change this 3 to a 2. Yeah, leave a sign if it doesn't really matter. What happened when you made these two numbers match, what happened to the picture?
Got rid of that little.
Got rid of that little loop.
Lima bean.
And we're a little bit behind,
Loopy.
but that would have been perfect for Valentine's Day, because what does that look like? A heart. And indeed, this is called a cardioid. A cardioid is a special Lima sign.
That's a hard.
Whenever these two numbers match, whenever those two numbers match, you have a cardioid. Cardioids are special Lima signs. They're still Lima beanie, but they don't have that little loop. They're called a cardioid. So again, back on the practice quiz, the old quizzes here. Question on the second quiz, the one down here at the bottom. It says, is R equals 8 minus a cosine a cardioid?
Yes.
Yes. Why?
Because they're both the same.
They're both 8.
Wow.
They're both 8. Number 4 on the side quiz over here. A cardioid is a special kind of Lima sign. Great. Okay. Now, some of you are thinking, okay, Mrs. Ford, why did you set your window from -6 to 6? Well, here's the deal. What's the biggest that, forget all this, what's the biggest cosine can be? Cosine oscillates between what and what? -1 and 1. So this value is going to be somewhere between -1 and 1, right?
Yeah.
So what's the very biggest that expression could be? Harvey, I expect you to know this.
5.
Yes, thank you, Harry
I got
Payton.
you.
So, if the biggest it can be is 5, it makes sense to set my window at 6, just to
Yes.
accommodate the whole picture.
Why is the biggest it can be is 5? 5, why?
I'm not going to answer that question. I want you to think about it. We just talked about it. Cosine is going to range between what?
1 and -1.
Okay, so what happens if you put -1 in there? Right? Okay, next equation, next type of equation.
Wait, put a -1.
Okay, so we talked about roses, we talked about Lima signs. All right, now we've got
Simple math.
this equation. Now, you're not going to be able to put this one into your calculator without doing what? That's not going to go in like this. What are you going to have to do with it?
Never said that before.
You're going to have to square root it. And actually, sometimes we have to put in both of them. That is the positive and the negative. Remember when you take the square root, it's plus or minus? So I usually put them both in, even though sometimes I don't actually have to.
Someone gave me that.
One is R1, one is R2. You're putting both equations in.
Oh, see, really nice.
What shape did you get? It's certainly not a rose, and it's certainly not a lima bean. How would you describe this one?
A racetrack. Figure 8.
Delaney says it looks like an infinity symbol. I call it a figure 8. But it certainly is an infinity symbol, or you might think of it as a clown's bow tie. Some people look at it that way. The Lone Ranger's mask. Lots of different ways to think about it. It's called a lemniscate.
You found that way too much.
A lemniscate.
You're not funny.
Now, this one is slanted, so it's kind of hard to tell. But does anybody have a guess how long these little pieces are, the branches? Anybody want to guess how long they are?
2 and 3.
They're 3. How do we know they're 3?
I don't know, 9 divided by
The
square.
square root of 9 is 3. If you look at the equation, it kind of looks like a rose equation. If this had been a rose, how long would these be? 9, right? Well, you have to square root both sides, so now they are only going to be 3. Change it to a cosine, graph it, see what happens when you change it to cosine. I bet you have an idea.
Alright.
Did you anticipate you'd get the same shape?
Nope.
Of course. But what happened? It's no longer diagonal, now it is
Orthogonal?
horizontal.
I'm just spitting out random answers.
So, back to the practice quizzes. Number 3 on the first quiz, number 3, a figure 8 is also known as a lemniscate.
I don't trust you.
And number 1 on the side quiz over here, draw a simple freehand sketch of a lemniscate. You would just draw a figure 8, right?
Does it have to be going by?
It could be diagonal or sideways, either way. All right, now we have one more kind of curve to talk about. And this is the most fun one, but it's different. So far we've talked about the rose, the limousin, and the lemniscate. Now we're going to talk about this equation. You will notice that there's no sine or cosine in this. There's no function, no trig function in it. That changes the way we have to set things up in our calculators. So I want you to go to mode, and I want you to change it into radians. We'll talk about why, just do it for now. Change it to radians. And now in our window, I've changed to radians, so theta min I want to stay at 0. But theta max I'm going to put at, no, because we'll talk about why not, but for theta max I want you to put it at 20 pi. So type in 20 pi. For theta step, I want you to put 0.1. And for x min and max, do negative 150 and positive 150. Again, we're going to talk about why all this is. I just want you to get it in. So we are in radians. We're going from 0 to, what did I say? 20 pi. And we're going negative 150 to 150. Now type in your right equation. You have to take out the lemniscate equations. Type in 2 theta and hit graph.
Should we change the y to 150?
Yep.
It's literally just okay, cool.
What'd you get? You got a spiral. This is called a spiral of Archimedes, or an Archimedean spiral. And what characterizes an Archimedean spiral is it starts at the pole and spins out. Now in a minute we're going to look at another kind of spiral. But a spiral of Archimedes, which is of the form R equals something theta, it doesn't have to be 2. R equals something theta is going to start at the pole and spin out. Now, why did I not do 0 to 2 pi? Almost always, we do 0 to 2 pi. Why did I choose not to do that?
Because it would have ended after one little circle.
Exactly. If I want it to spiral, it has to go around and around and around, right?
Yeah.
Every time around is 2 pi, so I said let's go to 20 pi. What did that accomplish? 20 pi got me 10 spins. If you made that number bigger, you would get more spins. Now, how did I choose the 150s? Well, what decimal is 20 pi? 62 or something? This equation is doubling that. What's 2 times 62? 120 something, right? So I said, okay, I gotta be bigger than 120, so I just rounded and got 150 to make my screen big enough to accommodate 10 spins. Got it? Now, why did I change to radians? Because radians are easier, or keep the number smaller. Think about
23.
10 spins in degrees. 10 spins in degrees would be 3,600. Your screen would have to be huge to accommodate. That would be 7,200 as an R value. So to keep it smaller, I do it in radians, because a spin in radians is only 6, 2 pi. A spin in degrees is 360. Okay? So on the quiz, first quiz, everything should be filled in except number 4. The origin is also known as the pole. In the quiz, second quiz underneath there, number 2, a spiral that starts at the pole and spins out. Archimedean, spiral of Archimedes.
Good job, girl.
And then we got a couple more to go. So here we go. Now let's graph. Now, do not put this equation in and do not hit graph until we modify our window. We're now going to graph this equation. We're going to leave our calculator in degrees, or excuse me, in radians, and we're going to leave the window at 0 to 20 pi. Okay? But now I got to change everything else. Okay? I'm not changing theta step. I'm leaving that at 0.1. But x min, boy, this is a guess on my part. I'm going to say x min is negative 0.01 and 0.01. So I'm going to go negative 0.01 to 0.01. And that's a guess on my part. I'm going to type in my equation, see what happens. 2 divided by theta.
Can't see anything.
I know, I may have made it too small. I have to wait a minute and see. I may have made it too small. Okay, let's go back to our window and let's make x min and max 0.1. There we go. What happened?
Just retracting.
Is it, did you see a spiral?
Yeah.
But this time, where did it start?
Out.
It started out here somewhere, right? And it finally came into view. That's called a hyperbolic spiral.
Assassinated already.
And a hyperbolic spiral starts out and spins in. Now, is it ever going to reach the pole? No, because this is never going to equal 0. R equals 0 is the pole. This is never going to equal 0, but it's going to keep getting smaller and smaller and smaller, which means it's going to get closer and closer and closer, but it's never actually going to get there.
I'm never good.
okay? You can graph, and somebody said yesterday, boy, this is kind of fun putting in all these equations and getting these shapes, and it is. You can graph whatever kinds of shapes you want. Just play around with it, type in some weird equations and see what happens. But what we have talked about here are called the 4 classical curves. When the Greeks started studying all this stuff, which by the way they did without graphing calculators, when they started studying all this stuff, they were fascinated by the beauty and symmetry of the curves. These 4, rose, limousin, lemniscate, spiral, are called the classical curves. They're the big families of curves that they studied extensively and wrote about. So what are the 4 classical curves? Rose, limousin, lemniscate, spiral. Right? We talked about hyperbolic and our Archimedean spirals. They're just different kinds of spirals. We have also talked about cardioids. They're just a special kind of limousin. But the big families of curves, rose, limousin, lemniscate, spiral. Okay, so
Down the pounder.
enough of that. Let's take a look then at last night's homework. Anybody have an issue with one of the problems in last night's homework?
That was fun.
Which one? Number 1. Find the rectangular coordinates for 3, 2 pi over 3. How do we find rectangular coordinates? First of all, what does it mean? What are we looking for? What are rectangular coordinates? We're looking for x and y. Madeline, what's x equal? Madeline, what's this? That's r. What's this? So how am I going to find x? These are the easy ones. Yeah. So that's just going to be 3 cosine 2 pi over 3. And y will be 3 sine 2 pi over 3. Yeah. Finding rectangular coordinates is literally a no-brainer. You just stick in r and theta.
See, Madeline, didn't I tell you that? But all we did was change that to degrees, which doesn't matter.
It doesn't matter.
Yeah.
If you can certainly change it in degrees, that would, if you're more comfortable working with the degree measure, that is absolutely fine. It's still theta. Yeah, so certainly you can do that. Change that into
People in college get confused every Wednesday.
I told her it's like 3 times.
Anybody else have a question about one of these problems? What?
The plotting one. Plot.
Can you tell me where we're plotting? 5. Complete the table for the polar equation and plot the points.
Will that be a test question? Possibly.
Well, why would it not be? I mean, it's easy. All we have to do is, it's like a T-chart. Now, they wrote their T-chart sideways. I prefer to do it up and down. And they're saying theta is pi over 4. Now, again, just like with Madeline, if you want to change these to degree measures, if you're more comfortable in degrees, then instead of pi over 4, it would be 45. And 90, and 150, 180, 240, and 360. So these are the theta values that they gave me, and I'm graphing 3 sine theta. So all I need to do is take 3, so like for here, it would be 3 sine 45. That's the number that's going to go here.
Oh, that's easy. Okay.
And sine of 45 is root 2 over 2. So we get 3 root 2 over 2.
Did you put that on the calculator?
Well, it would depend. All of these angles could be done without a calculator, but obviously if we threw it up 110 or something, you would have to use a calculator.
Okay.
All these can be done without. So then you get 3, and then, let's see, sine 150, 1/2, you get 3 halves, and so on. And then we're going to plot them. Now, I might need a calculator to get a decimal value for this, because I gotta plot this, and I'm not sure where to put it. But certainly 390. 390, I gave you graph paper. 390 means get on the 90 line and go out 3. So there's the point 390. 3 halves 150, get on the 150 line. Your paper is much better than mine, obviously, but this would be the 150 line. And 3 halves would be 1, 3 right there. So that would be that point.
Okay.
And then 180 would be 0, so that's just the pole. And 240, that's going to be another weird one. 240 will be negative. Oh, here, this is a good one to do.
Did your mom do that?
Let's see.
Doesn't that make sense? No.
3 sine 240. 240 has a 60-degree reference. I'm doing it without a calculator. And so this would be negative root 3, negative 1, and 2. So the sine is negative root 3 over 2. So this is going to be negative 3 root 3 over 2. Which decimally, because I want to plot that point. This is why we talked about what we talked about yesterday. It's like negative 2.6. Okay? Now, I can't plot negative 2.6 comma 240.
That's where you do.
I can't plot it with a negative r. So I have to remember this point, which came from my equation. I didn't make this up. It came right out of my equation. But this point is going to be plotted on what angle? Not 240.
Is it 60?
180.
60.
Minus
60. It's going to be plotted at 60. Because remember, what does a negative radius do?
Same thing.
It moves you from, in this case, quadrant 3 into the opposite quadrant, which would be quadrant 1. So instead of having a 60-degree angle in quadrant 3, I have a 60-degree angle in quadrant 1. So it would be plotted 2.6. This is the 60. So 2.6, it would be plotted like right there. Okay, Kate?
Yeah.
Read?
If we get a negative radius, as it's asking for the polar coordinates, do we have to switch it into positive? Or can we just
If it's asking for the rectangular coordinates, you mean?
No, I mean like if we just add the polar coordinates, do we leave it as a negative radius?
I'm trying to think of a question where that would ever happen. Because if you are changing into polar coordinates, r will always initially be positive. And if you're plotting points from an equation, if you're doing a graph, you have to change it to positive. So I can't think of, if someone said to you, find the rectangular coordinates, just like, let's come back to Madeline's problem. Let's say this had been the initial point. You can go ahead and do x equals negative 3 cosine 2 pi over 3. When you are changing into x and y, you can use the negative r if you want. But I can't think of a time when the negative r, that's what you're going to want to have, unless the problem literally says make sure r is negative. Then you're going to change your angle 180 degrees. So if you can find a problem, I'm just not understanding what question you're anticipating. Okay. All right. Well, our goal, our big picture goal, tonight you're going to do some graphing, which you're probably pretty good at. But our big picture goal for this chapter, or this little unit, is to be able to do this. We need to be able, this is our goal, we're not going to get to it today, we're not going to make it today, but our goal is to be able to find, let's say, the 5th root of 8 minus 8 root 3I. That's our goal. Believe it or not, as complicated and scary as that looks, I mean, think about it for a minute. You're taking the 5th root of a complex number, of an I, of an imaginary number. That's pretty wild. And as complicated as it looks, it's really pretty easy. But it takes a couple of skills. So here's the first skill that it requires. This number, 8 minus 8 root 3I, this number is in what we call complex form, standard form, rectangular form, and Cartesian form. All of those words are interchangeable, and you have to recognize that if any of these words are used, this is the kind of number we're talking about. Simply x plus yi. So in that number, the x is 8, and the y is negative 8 root 3. So a picture of that number would look like this. X, y. This would still be r. What would r be?
What were the letters for the I and J? You know, whatever it is. It's for why is like you know, like I thought was for X, like when we did like, you know, it's like
No, that's
put it in the I plus J thing.
Okay, this is not a vector. This is the complex. This is the square root of -1.
That's
Yes, you're exactly right.
Okay.
When we write a vector in terms of the horizontal and vertical unit components, I is associated with X. But this is not vector I.
Okay.
This is the square root of -1I. 16. And she got that the same way we always get it. She did the Pythagorean theorem. Now you should be able to eyeball this and tell me this angle.
Yep.
60.
That's a 60-degree angle.
Yep.
So the actual value of theta
That's a 2. Is a 300.
is 300. Now, listen. If we had started with 8 comma negative 8 root 3, if we had started with those same numbers as a point, this would be a coordinate pair here. Then we would say, okay, this x and y corresponds to 16 comma 300, that r and theta. That's what we talked about yesterday. You did that yesterday. You did that actually on your quiz yesterday. You found polar coordinates. This is a little bit different though, because this is not an ordered pair. We do it the same way. It's the same r and the same theta, but we have to write our answer differently. We can't write 16 comma 300 because we didn't start with a point. You see what I'm saying? So how are we going to write it? Well, remember, that was x plus yi. X is our cosine theta, and y is our sine theta. Over the years, this has been simplified is the right word. It's been rewritten like this. So, first of all, we're starting with x plus yi. This is x, this is y. So I factor out the R and move the I to the front. Is everybody okay with that? What do you not
Now
understand?
he was talking about something, I believe.
This is called the polar form or the trigonometric form. I have no idea why there's so many names for everything. There just are. So this is called polar form or trigonometric form. So our number, because it started out as a number, not as an ordered pair, we'll do everything the same. We'll find our R, we'll find our theta, but now we'll write it this way. So we'll write 16 cosine 300 plus I sine 300. That's the way we will write our answer. What I'm trying to impress upon you is, the math is not new. You get the 16 by doing the Pythagorean theorem, and then you get the reference, or you get the angle. Either, in this case it was special, so we knew it, or we do second tangent on our calculator. We gotta write our answer this way. Now, as we do more and more of these problems, this is going to get tedious, writing this out every time. We have a shortcut, which you are allowed to use. Instead of writing out all of that, you can write the number this way. 16 CIS 300. Now the 16 is the radius, the 300 is the theta. What do you think CIS stands for?
Cosine, imaginary.
Cosine, I sine. That's exactly right. So if you want to use longhand, that's super. If you want to use shorthand, that's super. Madeline?
Yeah.
What are you doing on your iPad? Oh, come on. You're kidding me, right?
I was paying attention more.
Because an email to your parents wasn't enough? What do I need to do now? I do. I need to confiscate the stupid thing, and I hope you don't need it the rest of the day because you're not going to have it the rest of the day. Give it to me. Now, again, I need to emphasize, because this is the biggest thing kids miss, actually. If we start with an ordered pair, 4, 5, when you answer that, it's going to be an ordered pair. You're going to figure out the radius and you're going to figure out the theta. Okay? Now, if we start with 4 plus 5i, we're going to have the same r and the same theta. You're going to do all the work exactly the same. The difference is your answer will look like that. If you start with a number, you have to end with a number. If you start with an ordered pair, you end with an ordered pair. Well, we'll talk more about that tomorrow, because we still have to hit our goal.
Never.